Hello, boys and girls. Welcome to lesson 10-1, Make Predictions. This is the first lesson from our unit on statistics. You can see here that statistics is one of our vocabulary words for today. Now, statistics deals with collecting, organizing, and interpreting data. For example, you can take a survey in our class and figure out what people do for fun and activities. I know some people like to do gaming, some people like social media, some people like to watch movies, and others just have different hobbies. Even if you collected what each person liked to do in the class and you wrote those down and then you displayed it in a bar graph or a pie chart, anything like that, you are doing statistics. You are collecting and organizing information. So now that you have an idea of what we're talking about, we're going to try to answer the question, how do you know which type of graph to use when displaying data? And the vocabulary we're going to look at is statistics, survey, population, and sample. Let's address the vocabulary first. Statistics deals with collecting, organizing, and interpreting data. A survey is a method of collecting information. So when you survey people and you ask them questions, and I know that some of you have done this in class for other projects, the group being studied is the population. Sometimes the population is very large. To save time and money, part of the group called a sample is surveyed. So statistics is the information that you collect. How do you collect it? Through a survey, a list of questions where people either check a box yes or no, true or false, or they get to choose different options. The people that you survey or ask the questions to is your population. Sometimes we cannot ask 30 million people, so we might ask 1,000 people, and that's our sample. And we use that sample to determine trends in our population. For each survey topic, determine which set represents the population and which represents a sample of the population. Write population or sample. Okay, so let's see. Survey topic. Dress code changes. Okay, so dress code changes meaning policy and whatnot. Set A, the students in a middle school. Okay, so I could do a survey about dress codes, what we wear as our uniforms and whatnot. And I could ask the students in the middle school, or I could ask the 7th graders in the middle school. So rather than asking the entire middle school, grade 6, 7, and 8, and asking every single class from what could be a huge school, I could just ask the 7th graders in the middle school. So if you said this is your population, you're correct. So let's pretend that when we say the students in the middle school, we're talking about every student at school, if the school is just a middle school. Or we could just pick one class out of the entire school. That would be our sample. Okay, favorite flavors of ice cream. The customers at an ice cream shop in the town, the residents of the town. So imagine we ask the entire residents of the town. Let's say this town could have 100,000 people. Or we could just ask the customers that are in the ice cream shop that day. And this, what we get from here could represent what the town likes. You see? So you can see how this one would be the sample and this one would be the entire population, correct? Okay, let's see a real world connection here. Logan wants to survey students in his school about their favorite and least favorite zoo exhibit. Describe a possible sample Logan could survey instead of surveying the entire school. So a possible sample could be a class. He could just pick a class out of the entire school and just see what he gets there. He could also take maybe 5 or 4 students from each classroom, starting from kindergarten all the way to the highest grade in elementary school, and take a sample from each classroom and see which one is their favorite or least favorite. I'm not going to write that down. I just really wanted you to understand how this applies to the real world, some real world content. So sometimes when we take a sample, we use that sample to determine what an entire population might like, or we call it to make predictions, right? So we make predictions using these ratios. What we mean by ratio, it's maybe we can say 3 out of 4 people like apples. That's a ratio, right? 3 out of 4. So you can use the results of a survey or past actions to predict the actions of a larger group. So you can use the information you got from a sample group to determine what a larger group might like. Since the ratios of the responses of a good sample are often the same as the ratios of the responses of the population. Now remember, you can't determine what 1,000 people might like based on what 5 people say, correct? But you might be able to determine or get a better idea what 1,000 people might like if you survey at least 100 people. Now that we understand the concepts that we're talking about, let's do some math. Example 1. The students in Mr. Blackwell's class brought photos from their summer break. The table shows how many students brought each type of photo. So let's see. Summer break photos. Location, students. So 6 students brought photos from the beach or on the beach. 4 students camping from their campground. 7 students brought pictures from home. And 11 students brought pictures from a theme park like Canada's Wonderland or Six Flags. Question 1. What is the probability that a student brought a photo taken at a theme park? Well, theme park is 11 photos. Out of how many photos? 11 photos were brought, right? 11 students, 11 students brought photos of theme park. Out of how many students? Well, here we have 10, right? 6 and 4 is 10. 17 plus 11 is 28. So 11, see, we have the probability. This is very similar to our probability lesson, probability of a theme park photo. We have the number of students, the number of theme park photos compared to the number of students with photo, or all the students, I should say. So we have 11 photos taken in a theme park compared to 28 possible photos. So the probability of a theme park photo is 11 out of 28. Okay, so that was 28 students, but let's look at example 2. There are 560 students at the school where Mr. Blackwell teaches. Predict how many students would bring in a photo taken at a theme park. So what are we doing? We're essentially just comparing ratios. Let S represent the number of the theme park photos. So we have 11 out of 28. Remember, 28 is the sample number that we took, but 560 is the entire school. What do we have to do to make the 28 into 560? Well, whatever you do to make this 28 to 560, we take this 11 to here. This looks very similar to the first lesson we had this year with ratios and rates. Let's see. Right, so we want to make an equivalent ratio. What do I have to do to 28? Multiply it by 20, and it gives me 560. So I do the same thing to the 11, multiply by 20, and 11 times 20 is 220. So we could say about 220 students would bring a photo of a theme park. Of the 560 students, you can expect about 220 to bring a photo from a theme park. Okay, now let's try practicing. Here we have a survey found that 6 out of every 10 students have a blog. 6 out of 10. Well, I know you guys can identify that 6 out of 10 is 6/10, which is 60%, right? I could just add a 0 here and add a 0 here, and we have our 60%, correct? But that's not what we're going to do. Let's just follow along. If you think you know how to do this, please pause and do it on your own and then check how I did it. But continuing on, what is the probability that a student at the school has a blog? At the school, okay. A survey found that 6 out of every 10 students have a blog. Wow, 6 out of 10, and we just did that. If we wanted to find it in percentages, we already figured out that it's 60%, right? Suppose there are about 250 students at the school. About how many have a blog? Now remember, if you want to find what 60% of this number is, you could also just take 250 times 0.6, and that's going to give you the 0.6. When you multiply, it's going to give you your 60% of this. But since we just learned how to do, or we reviewed, I should say, how to do equivalent ratios, we can set it up like this. So I have 6 over 10 equals, we'll make this S for students. S over 250. What did I do to 10 to make it 250? If you know what we're looking at here, whenever you multiply a number times 10, you're essentially just adding a 0 to the number, correct? So it's 25 times 10 is 250. So I multiply the 10 times 25. So I do the same thing to the 6. And when I multiply 6 times 25, I'm going to get 150. So about, you can say, about 150 students would have a blog in a school of 250 students. So therefore, about 150 would have a blog in a school of 250 students. Please copy this down. So just the same way we made predictions using ratios, you can also use the percent equation to make predictions. We have learned about the percent equation again back in either chapter 1 or chapter 2. Now let's take a look what this math looks like. A survey found that 85% of people use emojicons on their instant messengers. Predict how many of the 2,450 students at Washington Middle School use emojicons. So, what number of students is 85% of 2,450 students? Well, let n represent the number of students, and here's your equation. So the number of students is decimal 85, or we can say 8500th. This is how you turn a percent into a decimal, remember? Move the decimal over twice to the left if it's in the hundredth, okay? Well, if you're looking for the percent, sorry, even if it's in the tenth, you still move it over twice. So you move it twice to the left, and then you multiply times the number. Because when you multiply a number times a fraction of a number, or times a decimal, which is the same thing, you get the fraction of that number, okay? Or the percentages per se. So let's take a look here. We have decimal 85 times 2,450. Once you multiply the two, okay, you get 2,082.5. So about 2,083. Now you have to round up because you can't have half a person. So about 2,083 of the students use emojicons. Example 4. Let's take a look here. We have a pie chart, right? TVs in the bedroom. And we have 46% TVs in bedroom, 54% no TVs in bedrooms. Now, I would fall in the 54 percentile. We have no TVs in our bedrooms. So, the circle graph shows the results of a survey in which children ages 8 to 12 were asked whether they have a television in their bedroom. Predict how many out of 1,725 students would not have a television in their bedroom. Would not. So, would not. So, we're looking for 54% of 1,725. Correct? You can use the percent equation and the survey results to predict what part being represented by the variable P of the 1,725 students have no TV in their bedroom. So the part is the part that we're looking for. Part of this number is the percent times the whole. So 54%, you see written as a decimal, times the whole, will give you what 54% of this is when you multiply. and you get 931.5. Again, we cannot have a half a student, so we were going to run up to 32, correct? So about 932 students do not have a television in their bedroom out of 1,725. Okay, let's see this question. Refer to example 4. Predict how many out of 1,370 students have a television in their bedroom. So now we have been given another population, correct? And now we're looking for how many have. Now remember, the people that have are the 46%, as you can see right there, right? So we've been given a new sample population, right here, a new sample, okay? And now, and out of this sample, we want to figure out how many do have televisions, and it's 46%. So again, we'll have part, okay, equals percent times total number. Part equals our percent is 0.46, and our whole is 1,370, as you can see right there. And 46% of 1,370 is 630.2. So, therefore, about 630 students have TVs in their bedrooms. I round it to the nearest whole number. 0.2 is less than 0.5, so we just ignore it and we round down to 630 people. Okay, up next we have our guided practice. Here we go. There's our guided practice. Please go ahead, take a look through the guided practice, make sure that you feel comfortable with it. You can pause the video now and read through the questions. Take a look at the table of information collected that we've been given, okay? And go ahead and solve. Remember, you can use examples 1 and 2 in the video if you do not understand how to do 1 to 5. And you can use 4, 6. You can use examples 3 and 4, what we just used when we use the percentages, using percentages or the percent equation to solve. Here's your information, and here's what they're asking you to do. Go ahead and solve this now. Okay, everybody. See you in class.